Okay, so continuing on programming, we're going to continue talking about Java and programming languages in general. We'll talk about data types. We're going to see a lot of data types today, so I'll talk about that extensively. Again, learning to write some Java programs, look about how to get input from the user using the scanner class. And this is from the console, or what we used to call the DOS prompt. Some people call it the command prompt. Learn about variables and their types. The variables are used to store data, much like a variable in math. And we'll look at different types of statements for programming. Talk about constants, which is really only a read-only variable. Is all that is. We'll talk a little bit about classes, methods, and variables, although not very high level. We'll concentrate mostly on the Java primitive type, particularly the numeric primitive type. And look at some of the operators for doing arithmetic, multiplication, division, subtraction. So this is going to be very similar to what you might see in math. Look at some of what they call the math class and some of its capabilities. And talk about converting stuff from one data type to the other, like integers to floating points. And we'll look at how to do some mathematical formulas, getting the system time. And I don't know if we'll get through all this tonight, but we should get through a lot of it. Excuse me. Okay. Sorry about that. Okay, so converting different types. Talk about incrementing and decrementing values, post-increment and pre-decrement. Incrementing and decrementing values essentially means to add a value to a variable or to take a value away. And we'll talk about variables, but if anyone remembers in math, usage of variables in math, it's essentially the same thing. Talk about the character data type for characters, ABC, the string data type, and we looked at the J option pane last week for a message box. This week we'll look at it for an input box. And we'll look at a very simple Java program, and you may have this. Did everyone try to download the zip files from the CD to use? If you did, then you should have access to all this stuff. I can post it as well. I'm just going to get it myself. All right. So this is the first example that they're showing there. And we'll probably put this one into NetBeans. Compute area, which is right here. And I'm just going to go ahead back into NetBeans, and I'm going to reuse that same project that I used last time. Okay, what happened to that project? Okay, let's just go to a new project. Java, web, and computer. And let's just call this summer 12. Okay, so here's our source. And we can put everything under a default if we want. Maybe I'll just do that for now to keep it simple. And this is compute area. Okay. We'll go ahead and run this, and it doesn't really do very much when we run it. All it does is gives you this output right here. I don't know if everyone can see that or not. But it's the radius of the way it calculates it is radius times pi, it looks like, to give you that value. And this will go through it here. So it allocates that ratio. The first thing it does is it creates something called radius. And radius is a variable. And I don't know how much people remember from math something like, A equals 2 and B equals 4. And if C equals A times B, then C is equal to, what, 8, right? 2 times 4 is 8. Sound familiar from a math class somewhere along the line? Variables in programming languages do exactly the same thing. There's a little more to them than there is in math. In math, always assumes it's a number, and it's any type of number. Well, in computer languages, what we do is we type our variables, which means we don't assume that they're always numbers, or any type of number. For now, we're only going to look at the numeric data types, and for now, what I'm doing is, radius is the variable name, just like, A or B here. And what's directly before it is the type of variable it is. In this particular case, we're saying it's a double. Now, a double is the largest numeric type you can have in memory. I believe it uses 16 bytes, which is quite a bit. 16 or 32 bits. No, 32 bytes, I'm sorry. And this allows a very large, what we would call precision. We'll get over the size what it can hold, but a double is essentially the largest numeric value you can store in a computer, and we'll get into these ranges a little bit later. But for now, if you want to do something mathematically and you have no idea, how big that number will be, whether it'll be a whole number only or it'll have a fractional portion, doubles are always safe. They're not the most efficient on memory, but they are always safe. So, here what we're going to do is we are going to say that we're creating two variables, and they're going to be large numbers called radius and area. Okay, area is the second one. And this thing over here shows what the memory might look like. And here we're saying, okay, the radius has no value yet, and area has no value yet. We've just declared them in memory. It's like allocating a space. It's like renting an apartment, but you haven't moved any furniture in yet. Okay? It's there, but there's nothing in it. Okay? Now we're starting to put some numbers in it. Now we're moving some furniture into that apartment by saying radius is equal to 20. That stores the value 20 in there. The next thing we go in is we say area is equal to radius times 3.14 or times pi. That will essentially calculate this thing. 20 times 20 would be 400. Then times 3.14159, or something close to pi, would give us 1,256 and so forth and change. And that value is then stored in the memory location for area. So recall, you think about your computer has 4 gigabytes of RAM, and that a double takes, let's say, 32 bytes So it's taking a very small fraction of your gigabytes, a gigabyte being a billion, and 32 bytes is, it's like taking $32, having $1 billion in the bank, it's like having $4 billion in the bank and withdrawing $32. You're not even going to notice it. So it's nothing. It's absolutely nothing for the computer. But that's the memory you're using right there. A little bit of memory. So when you create variables, you're taking a little bit of that memory of that 4 gigabytes or 8 gigabytes if you have a really new computer or a high-end computer or something like that, and you're using it to store something in. That's what the memory's for. Okay, so that puts it into memory. Next, we're going to just simply print it out, saying, this is what the value actually is. Which, if we go back to our NetBeans, is this guy right here. Okay, the next thing we're going to look at is an example of how to input data. And I think we can go and get this thing from the slides. Let me see if I have them. Pretty sure I do. Yeah, I don't think I do, but that's okay. We'll just copy it. And I'll show you what we're going to do. So now what we're going to do is we're going to prompt the user for this. Oops, that didn't work. Copy. Paste. Alright. We have to import this guy. Let me see what this thing is called. Java. Okay, so we have to do an import of that little. I'll talk about what that's happening there in a moment. And any questions so far, by the way?